I just wanted to make a very quick video to clarify some of the issues that arose in group work today regarding the diabetic neuropathy question, which was case 3. So if we take a look at case 3, we discover we've got a patient with diabetic neuropathy, and they're found to have bilateral glove and stocking paresthesia in both hands and feet. And you should recall that paresthesia means a tingling sensation, and this is bilateral in the hands and feet. And you're asked whether this can be explained by the concept of a topographical or somatotopic representation in the somatosensory system. Now, what we mean by this topographical representation is the idea that's conjured up by the homunculus. Okay, so the homunculus relates to our topographical representation in the sensory system. It's the ultimate icon of this topographical representation, and essentially what the homunculus shows us is that adjacent regions of the body have an adjacent representation in the brain. And if we look at the homunculus, we find here is the hand and here is the foot. Now, what this means is that the hand and the foot sit nowhere near to each other in the sensory cortex. So this bilateral glove and stocking distribution cannot really be explained by, say, a tumour or something like that within the cerebral cortex, because it wouldn't only just affect the foot and the hand, but it would affect the other structures in between. So the fact that glove and stocking distribution does not fit with this sensory homunculus means that it cannot be represented by a topographical representation, and therefore is unlikely to be caused by a structural lesion. Topographical our glove and stocking distribution, we'll just draw it on a little stick man here. Okay, so there's our stick man, and these are the regions where we've got the sensory change. What helps us to explain this distribution in diabetic neuropathy is the fact that as one gets towards the distal extremities, the blood supply tends to be worse. Okay, so blood vessels supplying the fingers and toes tend to be smaller, and what that means is that they are more susceptible to damage by the diabetic process. Okay, so that's a major reason why we have this glove and stocking distribution, because of the differences in blood supply, the very small vessels that supply the extremities. That is the explanation for why we see this distribution. We're told that on examination the patient has complete sensory loss in the S1 dermatome on the right hand side, and you're asked to remind yourself about the S1 dermatome. I'm not going to remind you of that. It's a simple case of looking at the dermatome map, which all of you are quite capable of doing. But the thing that was confounding some of you was the next question relating to the structures that might have been damaged to cause this clinical picture, i.e. sensory loss in the S1 dermatome. And we can tackle this by drawing a transverse section through the cord. Okay, so here's our transverse section through the cord with our grey matter here. All right, and just reminding ourselves about the dorsal root with the DRG and the ventral root here, and those two roots coalescing to form the spinal nerve. Now, in this patient, we're told that they have complete sensory loss in the S1 dermatome. At this stage, we are not told about the motor function in this patient. And if we see complete sensory loss in a single dermatome, this suggests that the lesion is at this level of the cord and its associated roots. How do I know this? Well, I know that dermatomes are not represented really in our sensory tracts, or indeed in the sensory homunculus. Dermatomes as a concept exist at the level of the spinal nerves and roots, not within the cord tracts themselves or in the brain. Within the cord and the brain, we have a topographical representation. So you'll remember that the hand is supplied by a number of dermatomes. Okay, so 3 dermatomes supply the hand, but that in the brain, it's just a region of the brain that supplies the hand. So dermatomes don't feature in the cord and the brain. So this must mean it's at the level of the roots or the spinal nerves. And to give us a completely isolated sensory loss, our lesion would have to be at the level of the dorsal root. It could not be at the level of the spinal nerve because that is both mixed sensory and motor, and it could not be at the level of the ventral root because that would be purely motor. So to give us pure sensory signs in a dermatomal distribution, it must be in the dorsal root. Now, dorsal root lesions on their own caused by diabetes are relatively rare, and in fact frequently dorsal root lesions occur much less commonly than lesions of the spinal nerve, and in fact it's more likely that this patient has a spinal nerve lesion, a neuropathy affecting the S1 spinal nerve. And of course, if we examine the patient, we may find that they have weakness in myotomes supplied by the S1 spinal nerve itself. Okay, I hope that that's clarified things a little bit. If you're still unsure, please feel free to contact me through the usual lines of communication. Okay.